Alright, so in this video I want to talk about user-defined types and how we can go about writing our own types as opposed to just being limited to what's provided to us by the C++ language. Okay, so before we look at user-defined types and how we can go about writing our own, let's quickly review the built-in types that we've looked at recently. So we've looked at the int, the float, and the double, the char, and the bool. So with the int, the float, and the double, those were all used to represent some sort of numeric values. And with the float and the double, we could actually represent values that had a fractional part, so real number or approximation of real numbers. With the char, we could represent single character values, so anything that you see there on the keyboard in terms of alphabetic characters, both uppercase and lowercase, in addition to a lot of other symbols as well. And then the bool was used to store true-false values. So the C++ language, and specifically the C++ compiler, knows exactly how to handle these types and to handle the associated operations and what operations can actually be performed on these particular types. So many user-defined types were provided to us by the C++ standard library. And one of those user-defined types provided by the C++ standard library is the string type. And we've made use of that several times in the most recent programs. So we saw that with the string type, we could perform various operations. So we could get a size of a particular string, we could get a character at a particular position, and we could also make use of the assignment operation. So we could assign a particular string value, be it a literal or a variable, to another string variable. And what we'll find out is that whenever we build up our own types, our own user-defined types, that we'll be defining those types in terms of certain attributes and properties and also certain operations. So what operations can we perform on that type? What sort of state information or properties does that particular type have? And that's really what goes on when we start defining our own types. So whenever we start writing our own types, we'll often want to be able to define that particular thing, whatever it is, in terms of its properties and its operations. And in terms of the properties, sometimes you'll hear the terms attributes or state information, so what state that thing is in. But those are all related to the same idea. So we're going to look at two different examples here, one dealing with a bank account and the other one dealing with a television, and how we can actually model these particular things in terms of defining a user-defined type in terms of its properties and operations. So we'll first take the bank account. So with the bank account, there's a lot of properties that we can associate with it. One would be the customer's name, maybe their account number, their amount that they have in savings, the amount that they have in checking. So these are all properties that we associate with a particular bank account. And we could also associate operations. So the operation may be deposit, so deposit some amount of money into this particular account. Withdrawal, so that's the opposite of doing a deposit, being able to take money out of your account to use for some purpose. And then being able to maybe transfer some amount of money between different accounts that you may have on that specific bank account. So these are the various properties and operations that we'd like to model for this abstract concept of a bank account. Now, in terms of a television set, we can start thinking about the same sort of things. What are the properties and what are the operations? And maybe we'll use the term state information in terms of a television set as opposed to talking about properties. So for a television, we can think about the state of the power. So is the television on or off? What's the current channel setting? So are we on channel 10 or are we on channel 100? So that would be, what is the current state of the channel? The volume setting, so where is the volume set right now? Is it, the lowest setting or at the highest setting or somewhere in between? In addition to the state information, we could also talk about the operations. So we could talk about toggling the power on and off. So this would be a specific operation that we would do. And then in terms of changing channels, so we could have an operation that allows us to change the channel from something else. Maybe it's just simply going up a channel or going down a channel, or it may be actually using numeric keypad to punch in a specific channel. Also changing the volume, so being able to change the volume going up and down. So these would be specific operations that we could associate with a television set. So if we think about trying to translate these concepts of properties and operations into something in C++, we can start thinking about variables and functions. So the variables would be able to represent the properties or the state or the attributes of some specific thing, whereas the operations would be our functions. So these would allow us to actually manipulate and change the values associated with the properties or the state information. So if we move the channel up or down, that would actually change the state information of what channel we had. Or if we turn if the television set was currently on and we toggle the power off, that would be changing that state information. So these operations are actually working on or are manipulating those state values. Okay, so let's take a look at our problem statement for our next program. And whenever we develop this particular program, we'll look at a lot of the technical details in terms of defining our own type. So we want to write a program that models a virtual pet. So we'll assume that the pet has a weight and it can also be in a state of being hungry or not. And we can also feed this pet. So whenever we feed the pet, if the food weight is greater than or equal to 1/2 of the pet's weight, the pet will not be hungry, otherwise it will be hungry. And the weight added to the pet will be 1/4 of the food weight. So as we look at this problem statement, we can start thinking about the attributes or the properties or the state information associated with this virtual pet. So this virtual pet has a weight and it also has a state of being hungry or not. And we have this operation of being able to feed the pet, and whenever we feed the pet, it results in changing possibly the status of it being hungry or not, and it definitely affects the weight. So the weight is again changed by adding 1/4 of the food weight. So this is a very simplistic virtual pet right now. Later on we may come back and add in additional functionality to it and additional state information where we can possibly walk the pet or perform some sort of exercise where it can lose weight as opposed to just simply gaining weight as we feed it. So whenever we write this program, we'll probably make a few mistakes and it won't be perfect the first time through, but that's traditionally how things occur whenever you're developing a program. You come up with a design, implement that design, and then hopefully refine that design and make improvements upon it. So let's go over into Eclipse and start writing this program. Okay, so we're going to call this program Program 7. So I've already created a Program 7 project folder here. If you need to create one, you can pause the video at this time and do that. So go ahead and right-click on the Program 7 project folder, go to New, and we're going to select Header File. So go ahead and left-click on the header file, and we're going to specify that the name of this header file is just simply vpet.h for our virtual pet, and we'll select default C++ header template, and then click on Finish. So here we have our header file. We've already got the name associated with it. We also have these pound if not defined guards in place. So we had discussed that in our last video. So these are just to ensure that we're not doing multiple includes. So this just pops up automatically. And it's good to have these. So this prevents you from, or aids you in not having to actually type this in. So let's go ahead and talk a little bit about what we want to do here in the vpet.h file. So in the header file, we're going to be defining our interface for this thing that we're trying to define, this virtual pet. So in C++, we have this construct called a class. And a class allows us to define a blueprint or a template for describing something in terms of its properties and its operations, its attributes and operations, however you want to define those things. So let's go ahead and define a class called vpet. And the way we do that is just simply use the keyword class, and then we specify the name, and I'll just say vpet. And then I'm going to use open brace and then hit enter, and we should get a close brace, and it should have a semicolon at the very end. So this is just the syntax that we need to be using there. So whenever we define a class, we have keyword class, the name of the class, open brace, close brace, and then a semicolon. And here inside of this, we'll actually describe the members of this particular class. So the members can be data members or they can be function members. That's generally the classifications that we can have. And also, in addition to the data members and the function members, we can divide things up in terms of what's public and what's private. And what do we mean by that? So when we say something is public, we're saying that it's going to be available to the client of this particular class to use. And if we say something is private, we're saying that that thing is not available for them to directly manipulate. So if we go back to the example of our bank account, we probably want to provide them with a mechanism to be able to make deposit and withdrawals. So we'd want to have that functionality publicly available. Whereas if we're talking about the actual amounts that they had in checking and savings, so we may have some variable that represents how much they have in savings or how much they have in checking, we wouldn't want to allow them to directly manipulate those values. They could only manipulate those values through the interface, the public interface of doing a deposit or withdrawal. And it's going to be something similar here with our virtual pet. So let's go ahead and define the public part of our interface by using this keyword public and then a colon. Okay, so come down a line. It looks like the auto formatter here is putting this in the first column, but I'm going to tab this over. I probably need to change that. So go ahead and type in public, come down a couple of lines. And one of the first things that we'll provide to the user is a way to actually construct a new thing of this type. So we'd like to be able to create a new virtual pet. So this particular thing is what we call the constructor, and we'll just simply call the constructor vpet. So it turns out that anytime we have a function in which the name is the same name as the class, you'll see that our class here is called vpet, and we're defining here a function called vpet. Those particular functions are called constructors, and they're basically what's allowing us to initialize a new thing. So in our case, the constructor is going to have a couple of parameters here. We'll have one parameter for its weight, which will be of type int, and we'll have another parameter which will be of type boolean, which will be our hungry parameter, which basically tells us whether that particular virtual pet is hungry or not. And we also like to have the ability to construct a pet that maybe the user doesn't supply the weight and whether they're hungry or not. So we'll just define another constructor here, so you can have more than one constructor, and this will be our default constructor. So when we actually go in and create a source file that has all the implementation details, we will define some default values for the weight and whether the pet is hungry or not if the user decides to create a virtual pet and doesn't supply that information to us. Okay, so these things again were just simply our constructors. So one thing that we need to keep in mind here as we're writing the interface here is that we are defining a template for a certain thing. So what that means is that we'll be able to create as many virtual pets as we like, just like we could create as many bank accounts as we'd like. All right, so let's go down, and the next thing we're going to do is actually create just some functions, and we'll just label these as member functions. Technically, the constructors are also member functions as well. They're just special type of member functions, so maybe I'll write that comment in here as well. So go back down a couple of lines here where we have this comment, member functions. And we know from the problem statement that we would like to be able to feed our pet. So we'll just simply call a function feed pet. And we'll need to pass in the amount of food that we want to feed the pet. So I'm going to specify that that's going to be an integer value, and we'll just call it amount. This particular function is not going to return a value. It will be manipulating the weight, but it won't actually return anything. So we're going to have this as a void function. All right, so our next member function that we're going to write is just simply a function that returns whether our pet is hungry or not. So it's going to return a Boolean value, and we'll just call it get hungry. And it just simply gets the state of our pet, whether it's hungry or not. And then we'll also have another integer value that gets the weight. So we know that we can change the weight as we feed our pet. So every time we feed this pet, it's going to grow in some size. So we'll say get weight. That's the name of that function there. All right, so those are our member functions that are not constructors. And now we're getting to the point in our class where we're going to define the private parts. So I'm going to label that private. So that's another keyword in C++. And here we're going to have a lot of our what we call data members. So in general, the data members in our class will be private. And we don't want to have direct access to these. So in this case, we'll have a data member for weight, which will be of type int, and we'll also have one that's of type bool that we'll call hungry. So whenever we go and write the source file, we're going to be writing the implementation details for all of these things here, but in the case of our member functions, whenever we feed the pet a certain amount of food, then that will actually manipulate and change the weight. And also, depending on how much food is fed to the pet, it will change the status of whether the pet is hungry or not. So let's go ahead and write the implementation for all of these declarations here, so that we're going to go and actually write the function definitions in a separate file. Okay, so go ahead and save the vpet.h file, and now we're going to actually create the source file. So right click on program 7, go to new, and then go to source file, and now we'll just name the source file vpet, not vpet.cpp, and the template can be none, and click on finish. So the first thing that we'll do is bring in or include this header file into our source file. So we'll do a _include and then specify vpet.h. So what's going on here is whenever we compile this program, there's a thing called the preprocessor, and it actually brings in all of this stuff here. So effectively all this stuff is being pasted into the very beginning of this CPP file. Okay, so now let's look at actually writing our first member function, which will be for the constructor. And whenever we write a particular member function that's not inside the class, so we can see that we defined our class here in the vpet.h file, but we'll be defining the definition of those particular member functions here in vpet.cpp, and we'll have to specify what class we're actually referring to. And the way we do that is just specify the class name and then : : So once we do that, Eclipse is helping us out here and actually providing us a list of the member functions associated with the vpet class. So once we've done that, we'll just simply select the constructor here. And remember that the constructor is designed to initialize our data members. So our data members were for weight and also for whether it was hungry or not. So I'm going to just say int w and bool hun. Okay. And here, after that, we're going to do what's called an initialization list. So I'm going to have a colon, and then I'm going to specify the data members. So our data members, if we look back at vpet.h, was weight and hungry here. So this weight and hungry that we're specifying here is different from this weight and hungry here. We didn't even have to specify these values here. We could actually get away with just simply having int and bool here. It doesn't really matter there. We were just specifying the types here. This was a function declaration, and now we're specifying the function definition. Now in the function definition, we do have to actually specify some name associated with the type, because we were actually introducing these variables here. But these variables are just allowing us to pass in information. So whenever we go and create a new virtual pet, we will be able to invoke or call this particular function, this constructor here, and pass in values for the weight and whether it's hungry or not. And depending on those values, we can initialize our data members here, so weight and hungry. So the way we can do that is through an initialization or initializer list. So right after the function header, so all this stuff here is the function header, then we'll have a colon, and then we can specify weight being one of our data members, and then specify the variable here w, and then come over, comma, and then we'll specify hungry and use this particular variable name here called hun. And that, let me come down the line and do an open brace, close brace. So what we've effectively done here is created our constructor. And you can not have an initializer list, so what we've done here could be represented similarly. I'm going to cut this out for right now. We could similarly write the same thing by saying the data member hungry, and assign it, oops, let me do weight first. The data member weight and assign it the value of W, and then also having the data member hungry and assigning it the value of hun. So that's equivalent to what we had before. The only difference is whenever we call this constructor here, you're initializing it with some default values, and then you're overriding those default values. Whereas if you have the initialization list, it's not doing this this write operation to initialize this weight and hungry twice. Effectively, whenever we don't have the initializer list and we do it this way, we're basically doing an operation twice that we really shouldn't be doing. So the quicker way to do that is just to have the initializer list like this. So I'm going to get rid of that. That's the preferred, more elegant solution. The other thing is that you could actually have some situation in which maybe the constructor is being used before these values are properly initialized, where if you have the initializer list, you know you're getting a proper initialization straight away when it's created before you even go back and try to do anything else. All right, so let's move down a couple of lines, and now we'll do our other constructor, the default constructor. Remember that the default constructor doesn't have any formal parameters specified here, so don't forget that these were called formal parameters. So no formal parameters, and we'll have an initializer list, and we'll specify weight again, and we'll say that if the user doesn't specify a weight, we'll just assign a weight of 100. And these could be 100 pounds, 100 kilograms. It really doesn't matter. We're just using some value there. And then we'll say hungry, and we'll specify it as true. So if they don't supply us a weight or a hungry value, then this is what we'll have. Again, we need to have that open brace, close brace there, because this is a function. It's just that we don't really have anything in the function body. The other thing that you'll notice about these constructors is that they don't have a return type. So in addition to the constructor having the same name as the class, so VPET and VPET here, they also do not have a return type specified. And let me be clear by saying that this is the case for all constructors. It's not just simply our VPET constructors here. So any particular class that we create and the associated constructors will not have a return type. All right, so let's go ahead and create our next function, which is going to be for our feed pet. So that was a void returning function. Let's specify the name of the class, : and then we can select it from our list here. So Eclipse is nice and helping us out and providing a list of member functions. And what we have to pass in is the amount of food that we're going to feed the pet. And the first thing that we'll do is just look at the condition of how much we're actually feeding our pet, whether it's going to be hungry or not. So we'll say if, this is just according to our problem statement, if the amount is greater than or equal to 0.5 times the weight, then what do we know? We know that in that case, the hungry status will be false. So we'll set hungry to being false. Otherwise, else, the hungry status will be true. So this particular function here is actually modifying one of our data members, right? So our data members were for weight and hungry, and we just modified the hungry. And it also modifies the weight variable as well. So we know from our problem statement that the weight will just simply be the current weight plus 0.5 times the amount. And this is just some arbitrary thing that we came up with here for this particular problem statement, but that's how the weight is actually going to change. All right, so that is all we need to do in that particular function. Now, some of you may be asking whether we should change the weight after this condition. And yeah, we should do that. And the reason why is because we're doing a comparison between amount and weight, and we want to do that comparison before we've actually modified the weight here. Okay, let's write our next function. So our next function is just a basic get function. So that was our next two, get hungry and get weight. So the first one here for get weight is an int returning function. So int vpet : and this is for getting the weight. And this is a really simple function. It just simply returns the weight. Okay, so how easy is that? And then we're going to do another function similar to that, except this is a Boolean returning function, vpet, and this is for getting whether it's hungry or not. And we will return hungry. So with these two functions here, we're able to actually get or read what the current weight is and what the status is, whether the pet is hungry or not. If we did not have these functions here, we would have no mechanism to get to these data members here, because guess what? They are private, so we'd have no mechanism to get to the weight or whether it's hungry or not, other than performing these get weight and get hungry functions here, or calling these particular functions here. All right, so I think we're pretty much done, at least for now, in defining our class. So we defined the header file, which basically gave us our interface. Here's where we declared our class called vpet. We defined the public and the private parts. We defined two constructors, one of them being the default constructor if the user didn't specify anything to us. We also defined our member functions that allowed us to feed the pet and also get what the weight is, get whether they're hungry. The implementation or the actual definitions are over here in vpet.cpp. So we've done a good bit of work here in terms of just laying out the basic structure of defining a class, and also understanding this concept that when we're defining a class, we're looking at defining the data and operations of things. So let's go ahead and save this, and I know we'll get at least one compile time error message, but let's see if we get any more. So I'll go ahead and save everything, and then click on the build button and see what happens. So yeah, we did get one error message here, and that is that we do not have a main. So we cannot really build an application in C++ unless we have a main function. So what we'll do is actually create a third file that will have our main function. Okay, so let's go and create a file that actually has a main function. So over here on Program 7's project folder, right-click, go to New, and then select Source File. And the name of our source file is just going to be the same as the source folder, so we'll just call it program7.cpp. And click on Finish. And now we have our new source file here. And the first thing we'll do is pull in a couple of libraries. One library we need to pull in, or at least the header file for the library, is the IO stream, since we're going to be making use of cout. The other thing that we need to pull in is our header file for vpet, since we're going to be making use of that class. So let's go ahead and do a #include, and we'll do vpet.h. And we'll also do our using namespace standard. And then we'll come down a couple of lines, and now we'll define our main function. So int main open paren, close paren, open brace, close brace. So without this main function, we do not have a C++ application. We have to have a main function. But the cool thing is we've actually written this class over here for vpet, and now we're going to make use of it over here in program7.cpp. Okay, so the first thing that we're going to do is just simply create a brand new virtual pet. So we got to specify that we want to create a virtual pet. So this is basically the type. And we're going to just give a variable name here called Bob. So our virtual pets, whenever we defined it, they don't actually have a name as one of the attributes or one of the properties. So our data members is just simply the weight and whether they were hungry or not. So we had a Boolean value there. Later on, we can make improvements to this particular class and actually associate a string variable for the name. So maybe that will become a third data member. But for right now, we'll just assume that their name is associated with the variable name. Okay, so what we're going to do is actually invoke the constructor that we wrote. The very first constructor, which was not our default constructor, it actually expected two arguments to be supplied, one for the weight and one for whether they were hungry or not. So I'm going to just put in here open paren and say that the weight was maybe 150 and that that it was not hungry. So we'll put false here so we could have a true or false value there. So this is actually creating a brand new virtual pet for us through the invocation of that constructor and initializing it with the appropriate values. And the other thing that we'll do is actually feed Bob. So let's go ahead and feed Bob, and we'll say that we feed Bob. Well, I guess I need to invoke the function. So Bob dot, and then we'll specify the function, which would be feed pet, and maybe we only feed him 25, whatever the units may be. So these units could be kilograms, ounces. It really doesn't matter. This is just some unit of weight. So we've created Bob here, and we've also fed Bob. Let's create one more virtual pet. And this time, the virtual pet that we're going to create, we're going to just use the default constructor. And the way we do that is we just specify the type, and then we are going to specify the name. And maybe the name of this virtual pet is Sam. So you may be tempted to do an open paren, close paren here, but you should not do that. That is not going to actually invoke the default constructor. We just need to have vpet and then some name here, and this would actually invoke the default constructor. So no open paren, close paren there. And we'll also feed Sam. So we'll say Sam dot, and then we'll select our function, or you can type it out, and we'll say that we feed Sam 10 units. Okay, so we have that. So let's go ahead and do a couple of cout operations, and we'll say cout, and then say Bob weighs, and maybe a colon here, space, and then we'll use our little insertion operator again, and then we'll say Bob dot, and then we can just simply call on this function here called getWeight to find out how much Bob actually weighs. Because remember, we do not have direct access to Bob's weight. So we couldn't just simply do Bob dot, let me go back here and show you. We couldn't do Bob dot weight here. And the reason why we cannot do this whenever we would go and try to actually run this particular program, this is actually private information. We cannot get access to that. Actually, let me go ahead and show that to you. Let me go ahead and add a return 0 down here and a semicolon. Go ahead and save all this and build it. Okay, so we get an error message down here. It says weight is private, so we cannot do that there. That's why we had our little function there called getWeight. So getWeight allows us to get to that private data member. But the cool thing is we can only do a read of the weight. We cannot actually change the weight. So if we had unrestricted access, if we had that weight as being public, we could actually modify the weight. But that's not how we want to have the clients of this class working on the weight. We only want the weight changing whenever we feed the pet, at least for right now. If we add in walking or exercising later on, maybe Bob can lose weight, so we'll be manipulating the variable that way. So let's do another cout operation, and we'll say Sam weighs, and we'll use our insertion operator, Sam dot getWeight. Okay. So these getWeight functions are dependent upon which particular virtual pet we're talking about. So if we're talking about Bob, we're getting Bob's weight here. If we're talking about Sam, we're getting Sam's weight. So that's an interesting concept. We cannot just simply specify getWeight. That will not work. So let me save that and just show you what happens if we try to specify things like that. So I'll compile this, and it gives us an error message. It says getWeight was not declared in the scope. So what it's expecting is this is a function that maybe we should have declared inside of this particular program here, but it doesn't recognize getWeight. We would have to specify what particular virtual pet we're talking about. So we're talking about Bob. So Bob.getWeight. Okay. I'll save that and compile again just to show that we do not get any error messages there. All right, so now that we have this, let's just go ahead and we've already compiled it. So we did a build here, so that compiled it. We didn't get any error messages. Let me go ahead and run this program and see what we get. So we get Bob weighs 156 and Sam weighs 102. Notice that we didn't get any sort of fractional part here, and you probably would expect that we would have gotten a fractional part whenever we did these operations, because whenever we did our multiplication, right, we were doing a multiplication of the weight by 0.25 So 0.25 times 10 would be 2.5, and we didn't actually get a 0.5 onto the weight here. That just got lopped off, and the reason why is we have the weight defined as an int value. So the weight here was defined as an int. Get weight is returning an int value. Let's actually go in and change these to doubles, since that would make more sense in terms of not losing that fractional part and it just being lopped off. So we'll go in here and change all of our ints to doubles. So there's three places that we had to change int to doubles. 2 times here inside of vpet. So we had to change this guy to a double. We had to change the weight to a double here. And then we also had to change the return type here for the get weight definition inside of vpet.cpp. So make sure you make those changes. So go ahead and save all those. We'll build once again. And let's run our program. So yeah, this time we actually get the fractional part. We get to 156.25 and 102.5. So let's go back over here to program 7 and maybe add in one more thing. Let's test out our getHungry function. So our getHungry function returns a true-false value. So we can do something like this. Maybe we can ask the question and see if Bob.getHungry. So we'll do a getHungry there. So we know that that returns a true-false value. So if this turns out to be true, we'll just do a cout operation and come in here and say Bob is hungry. And we'll do an endl here. Else, what do? We'll say cout Bob is not hungry. Okay, so let's go ahead and save that, build it, and we'll see what happens. All right, so we got the same information as before, and we also got the statement here that Bob was hungry. Now notice that when we first created Bob, he wasn't hungry. We specified the hungry attribute as being false. But whenever we fed Bob, notice that whenever we fed Bob here, we fed him 25. And what was our condition there for him not to be hungry? Well, the amount of food that we fed him had to be greater than or equal to half the weight. So Bob weighed 150 pounds, right? So whenever we fed him 25, that was not half of Bob's weight. So half of 150 would be 75. So 75 is greater than 25, or 25 is less than 75 is maybe the way we should think about it. So it did not meet this criteria for him not to be hungry. So I guess, we kind of whet Bob's appetite there and made him hungry by feeding him, and it wasn't quite enough food to satiate Bob. So that is not a good thing, I guess, for Bob, but that's okay. We got a virtual pet going on here, and maybe we can feed him some more later on. The thing about it is now Bob weighs more, and we'll have to feed him more. He's kind of a blob, Bob the blob. Okay, so I think that's pretty much most of what I wanted to talk about for this particular program for now. We want to make some improvements on it in the future. The other thing is, if we tried, some of you may be thinking, oh, well, why not just do cout and then specify Bob and then do endl. So maybe you think that if we can just do this, we can print out Bob's weight and also whether he's hungry or not. But if we try to compile this code, you'll notice that we get a lot of stuff going on here. And if we scroll back up to the very top here, near the top, here on the console window, we notice that we don't have a match here for this insertion operator. So the insertion operator knows how to work on our types like strings, ints, doubles, everything that we've used so far, but we've defined a new type here called vpet, virtual pet, and it has no idea how to handle that. So Bob is of type virtual pet, and it doesn't know how to perform that particular insertion operation for that. But what we can do is actually perform what's called operator overloading, and we'll probably look at that in an upcoming video where we can actually go in and define the behavior that we'd like to have when we perform this insertion operation. So let's go ahead and just remove this line of code right now since we don't have an actual overloading of the insertion operator. Save everything, build it just so we have a complete clean compile and linkage, and we'll run it one more time. All right, so that's pretty much it for this particular video. In the next video, we'll talk maybe a little bit more about this program, and certainly coming up soon, we'll look at operator overloading.